I think legitimate excitement came around the announcement that two large teams at the Large Hadron Collider at CERN had finally found real evidence for the Higgs boson. They announced it July 4, 2012. That was capping more than half a century of concerted effort just to find that one particle, that one form of matter. We wanted answers to larger questions too, like why objects have mass. Many experts had coalesced around the idea that there might be this additional kind of particle, the fundamental particle that was later named in honor of Peter Higgs. Fundamental particles are governed by mathematical symmetries. They have ranges, bandwidth, patterns, like music. In trying to create resonance between these symmetries in the interactions that physicists mapped out for the particles, a revolutionary idea was born. What if these particles don't have any mass of their own, but their mass is induced because they interact with some other kind of matter that no one had even thought about before? In the absence of the Higgs field, particles would zip around at the speed of light. The nuclear forces attached to them would be infinite in range. But instead, the fundamental particles have short range and are immersed in this kind of molasses, a cosmic molasses, and that molasses is what we now identify as a Higgs field. It lends them mass.
You're now in the heart of one. Go on, smash things together. You wrap them up to faster speeds by extending the string between your controllers. The more you stretch the string, the higher the pitch of your experiment and the faster your protons are. Let the music of the universe be your guide.
If you could basically chip off a piece of that field, excite individual particles or quanta of that field, you'd get the Higgs boson. Most of the time, the fields are quiescent. They're in a kind of vacuum, a minimum energy state. But if you really kick them, if you really excite them, you can create an actual particle. A particle that is associated with the field you just excited. In this case, a Higgs.
By extending the strings between the particles, you speed them up.
Until particle accelerators, like the Large Hadron Collider, were created, we wouldn't have been able to do these experiments.
Press the red buttons to send the particles to the Large Collider. You're now ready to create a collision. Use your controllers to align the circles. By aligning the circles, you smash the particles together.
Before the Higgs, at the early stages of the universe, as it expanded and stretched, every particle was without mass. Higgs gave the universe its mass.
Maybe change.
Okay.